I made a promise, and I'm gonna keep the promise. We're starting at 8 p.m. exactly. This is gonna be a little faster day 3, okay? Because we only got halfway through day 2. It is a boot camp. We are trying to cram a lot of highly important information to make sure that y'all are ready to take that next step into Python, right? We're gonna try to speed up a little today because I want to make some ground. We gotta get through all of day 3. That way we get back on track. If we could do that, I'm gonna feel really good about day 4 on Tuesday. We're gonna have a ton of homework, okay? So let's load in again. This is the notebook we've been using, right? I'm just gonna connect it. Some of you might see this Colab AI thing here. It's neat. I'll do it after the instruction, but Colab actually ended up implementing their own large language model in the background. And so when you open new cells, it will ask you to start coding or generate with AI. You can ignore the generate with AI part for now. I'm just gonna run through everything. I'm just gonna hit run all. And this is just gonna go through all of my day 1 stuff. And it's gonna catch me up all the way into where we got to with day 2. So the next thing we wanna do is say we wanted to, rather than just knowing how often they threw a strike, some of these pitchers, they might throw a pitch type, but that pitch type, they might only throw like once or twice in the entire year. For instance, Justin Wilson, he throws a lot of strikes. It's possible that he throws a lot of strikes because he's really good, or it's also possible that he throws a lot of strikes because he didn't have a lot of pitches, and so each pitch impacts his average by a lot, right? So sometimes when you see like values that are really high, like Derek Law, 4-seam fastball, 70% of the time this is thrown for a strike. It's like, oh, why doesn't he throw his fastball all the time? Well, it's possible that he only throws it a few times because he might not have the best control over it. It's not something he feels comfortable throwing all the time. So sometimes you just throw a pitch just to get a little mix, have the batter have something else to think about in there. So it's possible that Derek Law doesn't throw his 4-seam fastball a ton. So let's see if that's true. 71% of the time for a strike. And the way that we'll do that is we'll also include a count variable, okay? So if we go to edit, we'll do this in a spreadsheet first. And this should be easy, especially for you people who are spreadsheet connoisseurs. So all we gotta do is, in values, we're just gonna add something and count over it, okay? It doesn't necessarily matter specifically what we count over, but I'm just gonna use pitch name because it makes sense. How many times did you throw this particular pitch? Let's count how many times you threw a particular pitch. So we'll do count, and we'll change this to, I think it's count. Count A. I think count A is like any value in the array or something. And then you'll see here at the top, we'll have a new column called count A of pitch, right next to our average. And you can see sometimes, like Chase Anderson, he'll throw his fastball 128 times, but then he'll throw his changeup, he threw that 140 times, right? So he threw that pitch a lot, and he threw it for strikes. So that's pretty good. But you can see down here, like, Fernando Cruz threw a sinker only 5 times, right? So 60% of the time, that means 3 of the 5 times he threw that, he threw it for strikes, right? That doesn't sound like a ton to me, so it's hard to really include that as part of his arsenal. Derek Law, 71% of the time he threw this for a strike, threw his 4-seam fastball for a strike. But if we look at how many times he threw this pitch, he threw it 21 times, which it might sound like a lot, but over the course of a season, 21 times, that might be like once, a week. It's not a lot. So he doesn't throw it too often, and when he does throw it for a strike, right? And that's the same, and you can see that with the cutter. He throws the cutter a lot. And then he mixes up with his other pitches too. And then you can see like the difference between someone who's relief pitching pitching in relief, versus a starter like Nick Lodolo, who pitched, and you can see how many times he threw these pitches, right? He threw his four-seam fastball 500 times. He threw his curveball 500 times. His least thrown pitch, his changeup, he threw 185 times, which is more than Derek Law's primary pitch he threw, right? Like here's Mike Minor, who was a starter for us in 2022. He throws his sinker, but he only threw it 4 times the entire year, right? So he started and he threw 1,700 pitches, but only 4 of those were sinker pitch types, and only 2 of the 4 were thrown for strike. So it's the context. It might seem like a good pitch based off the average, but how often did the guy actually throw it? You're going to need a count or some sort of usage, right? Okay, so just to reiterate, the way we did that is we just added the value. We used pitch name and we used count A, because apparently that's what counts over a string as well. And since all of these things in pitch name are strings, it makes sense to use count A instead of just regular count, right? So let's do that using the aggregation information we had before, right? So let's just copy this entire line, and we're going to redo a few of these things. First, we're gonna call this df2. We're just gonna save this as a new thing. We know we want Reds pitcher. That's the same thing. Is strike, there's a value in is strike, 0s and 1s. We'll rename this at the end anyway, so feel free to just leave is strike in there. We'll group by pitcher name and pitch name. We'll use the as index equals false keyword argument here because we're going to ultimately do something with both of these tables at the end of it. And then rather than mean, we'll count. Nice. Okay, so if we run that, basically the only thing you're changing is, instead of aggregating by mean, you're just aggregating by count, right? Instead of mean, you're changing your group by aggregation from mean to count. And now you have a column with the count of each pitch type that a pitcher threw, right? So if we scroll all the way up here for Chase Anderson, rather than seeing 4.37 and 5.42 for his four seam and changeup, we're gonna see 1.28 and 1.40. And that's exactly what's happening, right? So we see Chase Anderson four seam fastball, 1.28, Chase Anderson changeup, 1.40. And then if we scroll up a little, that other DF1, we have that at 4.37 and 5.42. All right, so if we want to truly have something that looks like this table, then we're going to want to merge or join our 2 data frames here. So before we do that, we're going to want to rename some of these columns. So renaming columns is actually pretty easy. All you got to do is use the rename function, and specifically you have to rename the columns. So you'll do a rename columns, and then inside of rename columns, you're going to use what's called a dictionary, or these curly brace notation, right? And basically this is going to take a key and then a value. That's what a dictionary does. You're going to take the key, which is the thing that you have in your data frame, and then you're going to rename it to whatever the value is. So in this case, if I wanted to rename is strike, we'll type in is strike, and then we'll put a colon in there. That way we could separate the key from the value. And then the value we're going to change this to is count. So put in the word count. Okay. So again, we're going to do dot rename, parentheses. Then we'll say columns, because we want to rename our column, equals curly braces, And then the notation inside the curly braces for a dictionary, this is called a dictionary, is key, colon, value, okay? The key in this case, the thing we want to rename, is this column called isStrike, colon, and then the thing we want to change it to is count, okay? So if we run that, you'll see the name is now changed to count. Since we haven't overridden anything, right? If we type in df2 still, you'll still see it says isStrike. This is one of those first kind of confusing points for people in the world of Python, because over here, I wanted to rename this column to count. I would just type in the word count. And then whenever this decides to load in, there we go, this changes to the word count. So there is no like, it's always overwriting, saving over whatever you did in it, right? So I'll just undo that so we have the same column still. But in Python, it makes you explicitly say whether or not you want to save over something, right? So if you rename something and you're like, oh, fuck, I didn't want to rename that. Well, never fear. Unless you overwrote it, it hasn't saved yet. So sometimes I just like doing this stuff and throwing in a head just to make sure that it is what I want. And when I see it and I'm like, oh yeah, I want this to be renamed count, then I'll just save over it now. Now that's df2. And now when I look at df2, since I've saved over the df2 variable, I have count and it's there instead of isStrike because I've overridden our df2 variable. Okay. And we can actually do the same thing here. Well, let's copy this and let's do the same thing with df1. What did you do to overwrite? We're going to do this with df1, okay? So same thing with df1. So we'll change this to df1. And rather than overwriting, we'll just do it this way. And rather than saying isStrike and then renaming it to count, since this is the average, right? Let's just change this to AVG, which is short for average, okay? So when we run this, you'll see that it says average, right? It's renamed from isStrike to average now. But if we run df1 in another cell, if we just look at the head here, you'll see that it still says isStrike because we haven't overridden the df1 variable, right? We did df1 equals the group by, but we haven't done df1 equals the rename. So since we're modifying our data frame, if we want to keep that information, let's overwrite our variable. We'll just say df1 equals df1.rename. We're renaming the columns, and we're going to rename our isStrike column to AVG, short for average. Okay? So when we run that, and then we look at df1 head now, you'll see that it'll say pitch name, average, and same thing here. And we can actually move this line up under our other df2 line, just like how we did that with df1, right? So we'll do df2 equals the group by count. Then we'll do df2 rename the column isStrike, renaming it to count. We'll run that. And then we'll type in df2.head. And now we have pitch name, counts, rather than isStrike. But yeah, feel free to like space things out. If you want to write comments like this is where we rename, you could use that. You could use the pound sign or the hashtag symbol for those who don't know what the pound sign is to write a comment. And I do recommend writing comments, writing notes and stuff just so you remember what's going on. And you can see if we run through this again, it doesn't matter if there's a bunch of lines, it doesn't matter if there's a comment in there, these 2 lines of code is where everything's happening. So now we have our df1 and our df2. We've renamed one of the columns to average. We renamed another column to count. And so to get a data frame that looks like this, picture name, pitch name, average, and count, let's merge or join our 2 data frames. So if you have one set of information from one data frame, or let's call it a table, and you have another set of information from another data frame, you can actually take those 2 and merge them together, join them together, so you have it all in one place. That way you could combine a lot of different tables of information, a lot of different data frames of info, put them all in one frame, and then you can have access to all of it in one place. That way you could do a lot more than just looking at strikes or looking at counts. You can maybe join like biographical info or physical attributes like height and weight or age. Maybe how long they've been in the league, or if they've ever played for other teams. If all that stuff lives in other data frames, other tables, other sources of info, that might come in as a data frame, and you might need to join it onto your bigger main data frame, right? Let's do that with df1 and df2. So df1, we'll type in df1, and we're going to join, in this case, in pandas, the function is called merge. So we'll do .merge. We'll take df1, and we'll do a parentheses, and then this might sound really complex because we're joining onto like specific, like, do we have to go row by row? Do we have to like say exactly what we're doing? Well, the beauty of pandas is that a lot of things are implicit. So for instance, if you know the data frame you're working with, like I know we have a data frame that has 3 columns here, and 2 of the columns are picture name and pitch name. And then I have 3 columns in my other data frame, and 1 column is picture name and the other column is pitch name. I know that if I merge, it's going to look for the same column names. And if it says the same picture name and the same pitch name, it's going to join or merge that info onto that same row. So we actually don't need to define anything here in pandas in this particular case, and I'll show you how to explicitly do this in a second. But if we do df1.merge, and inside the merge you type in df2, and you hit enter, you'll now have a data frame that is 146 rows, and it will have the picture name, the pitch name, the average, and the count, just like our pivot table, right? Picture name, pitch name, average, and count. Okay, so this is merge, right? So we took one data frame, df1, renamed one of the columns, and then we took another data frame, df2, renamed one of those columns to count. Then since one of these data frames, picture name, pitch name, has shared column names with this other data frame, when we did the merge, it found those column names and said, okay, let's try to merge everything across all the like indices or indexers, all the like values within these 2 data frames. And so it went through, it looked for all the times Chase Anderson first seam fastball occurred, and then it joined the average and the count. So this just lives nowhere, right? We wouldn't be able to access this at all, right? So if we set this to df3, if we say df3 equals this merge, and we type in df3 now you have access to this info. And just like before, if you wanted to access the average column, you could type in square brackets average. If you want to access the count column, you could type in square brackets count, just like how we did on day one, right? So df3 now exists. Now, let's go back to that merge, just because I know it looks very simple to merge like this, but I do want to teach you some rules of the road here. If you try to do this with any other examples or examples in the wild, or you go in as an intern and you try to do a join and like it crashes the database, it might be because you aren't setting enough joins on to certain columns that you're indexing over, right? Sometimes we want to explicitly state what we're merging on. For example, say if I just comment out df1, right? And now this is strike still. Okay, and if I comment out df2, the rename, right? And then this is df2, and this also says is strike. If I merge, since all three of these column names are the same, what it's going to do is it's going to try to find all the times is strike 0.437 is the same over here, as well as Chase Anderson forcing fastball. So it's going to try to match all three of these things with the same row over here. And as we know, all of these numbers in his strike are decimal or float types, and all of these values here in df2, they're all integers because they're counting, right? So if we do this merge, the behavior, it's going to merge, and it's going to say you're merging onto an integer and float columns. It says, it gives you this warning. That's fine. But if we print this, it's actually going to give you, oh, apparently it does give you info. That's crazy. This shouldn't have given me anything, but I understand why. It gives me a data frame of 2 people, or 2 rows of Kyle Zimmer, changeup, and curveball. And the reason it's giving me Kyle Zimmer, changeup, and curveball is because if we scroll all the way down to Kyle Zimmer, he threw a changeup for a strike, and he only threw it 1 time. So this is 1 and 1. And it's the same here. He threw his curveball 1 time, and he threw it for a strike. So it found the time where is strike average and is strike count were the same, and the only time it was the same was for this pitcher, Kyle Zimmer, for his 2 pitch types that he threw 1 time in the entire season. So sometimes this behavior kind of messes you up because sometimes you don't want to join on all these columns. So how do we specify what columns we're joining on? We could actually type, just like we're doing key value parameters again. So if you type comma, just like how we did with the group by, right? When we did group by, comma, as index equals false, we're going to do something similar. So key value parameter on equals. So on is what column names do you want to join onto? What column names do you want to merge onto? And so if we specify pitcher name, pitch name, so I'm merging onto df2, and specifically I want to merge on these 2 columns instead of, you know, all 3 of these column names. When I run this, I'm going to get back all my rows, 146 rows, and instead of average and count, because we didn't rename them, we merged onto pitcher name and pitch name, and is strike X, and there's also now a column called is strike Y. And the reason there's an is strike X and an is strike Y is because these were the same names here and here, right? They were the same names. But because we didn't join on them, and because Pandas wants unique column names, it renamed them for us. So is strike X would be what we call the left data frame. So it's renaming the left data frame X. And then is strike Y belongs to the is strike column of the right data frame. But these names are a little silly, right? So I'm just gonna uncomment our renaming here. I'll just rerun those cells again. I'll rerun the cell here, get my average, rerun my cell here. And even though we have different names and we could just not use on equals, that's fine. You could leave this in and it's no harm, and it's actually good coding practice a lot of the time to make sure you're explicitly joining onto the things you want to join onto, right? Especially when you're doing something like a code review, you might be asked by your code reviewer, hey, what are the things you're joining onto here? You might be, at the company you work at, maybe that's something that's a requirement in your good coding practices. So explicitly saying what you're joining onto is good. So in this case, we're explicitly joining onto pitcher name and pitch name. We've set that equal to df3, and when we run df3, we have average and count now. Okay. We're chugging along here. I think we're going to be able to get through all the stuff that I wanted to get through today. So this is great, chat. I'm glad y'all are keeping up. Let's try to make some data visualization. Okay. I think one of the things in data science and data analytics that's really important, it's not just synthesizing information, but also communicating that information in clean, clear, accurate, and also easy to interpret ways, and data visualization does just that. We're gonna relate all the stuff that you would typically see in the world of like business analytics, business intelligence. If you're working in Excel, then you've done this a million times. So say I wanted to get a bar plot, and I wanna do a bar plot of Hunter Green and his pitch types. I think pretty easily I would just like highlight this stuff, this area, these cells. Then we'll go insert chart. Okay, insert chart. And we're already getting like a predefined chart in here. So I'll call this a bar chart. Let's do a bar chart here. Okay, that's looking pretty good. And then we'll use column B as labels. Okay, and then that's these. These are the labels. And then it's trying to calculate two things. One is the count and one is the strikes. So I'm actually going to minimize this. I don't want the D column. I will not give them the D. I will do the C column only. Okay, so now I have this data visualization for Hunter Green, the 3 pitches he throws, 4-seam fastball, changeup, slider, how often he throws that for strikes. Okay, simple data visualization. There's definitely more complex we could do, but let's start simple. Just like how we started with, total score is one column plus another. Starting simple. So let's recreate this in Python. So we'll use our df3 table, right? This has the same information that we have in our pivot table. So we should be able to use this exact table, this exact data frame, and recreate the data visualization, okay? So the first thing we want to do is let's just make sure we could get to it, right? So I know the, let's make a variable, like, how we do X, how we do DF, DF1, 2, 3. Let's make one called pitcher name. And I want to look up Green, comma, Hunter, okay? Because his name in pitcher name is Green, comma, Hunter. Okay, so we'll make a variable called pitcher name. And if you want to check just to make sure pitcher name is correct, you could always run that in another cell, and it should look like this. Green, comma, Hunter. Welcome back, TJ. Okay, so pitcher name equals Green, comma, Hunter. All right. Now we're going to take our data frame, df3, and then we're going to do a loc, right? This is just like how we did this before. Just like in day one when we were doing conditional filtering, So we'll do df3 picture name. And because I know I want to do this for picture name Hunter Green, I could put my variable here, and I get my 3 rows. And those are the same 3 rows inside of that pivot table, right? So I typed picture name as the variable, just like we did in day 1, setting variables. And then just like we did in day 1 as well, I'm setting this, I'm conditionally filtering this info, okay? Now let's do what we did today, and let's just call this df. I usually like calling it dfplt because it's like a nice shorthand for me to know that I'm going to use this for plotting. You don't have to call it dfplt. You could call it df data viz, df graph, df dv, df art, df draw, whatever you want. You don't even have to call it df. I'm going to call it dfplt. And so if I type in dfplt, I will have this variable that's specific to only Hunter Green now. Let's make the data visualization. We're going to do an import, just like we did on day 1. We imported libraries, we imported packages. We're going to import 2 packages, okay? I'm going to import 2 packages. The first package we're going to import is the base package for plotting statistical data visualization in Python. Everyone uses this, matplotlib.pyplot. And we're going to import that as PLT. So import matplotlib.pyplot as PLT. This library actually stands for MATLAB Plotting Library. And MATLAB, the software, the coding language, MATLAB, that's actually short for Matrices Laboratory. Right? It's actually short for Matrices Laboratory. So wouldn't it make sense if it was pronounced MATLAB, not MATLAB? Because it's not matrices. It's not like you're doing a lab on your mattress. You're doing lab grade science on matrix data, not a mattress. MATLAB, right? So that would beget the information here. This should be pronounced mateplot, right? Mateplot. And of course, this is library. So it's not matplotlib, it's actually mateplotlib. I had a friend get so mad at me for pronouncing it mateplotlib. He refers to this only as MPL now. So we're going to import from MPL or matplotlib, or for the real ones, mateplotlib .pyplot. And we're going to import that as PLT. And then we're going to import one more thing. This is a convenience library to make it easier to work with data visualization in Python without having to do a lot of like custom syntax. We're going to import something called Seaborn as SNS. Now you might be wondering, why is it SNS and not SB? Well, you could change this to SB if you want. A lot of people do that, but the developer, shout out to Mark, he uses SNS. Okay, let's load those. Import matplotlib as PLT and import Seaborn as SNS. Matplotlib.pyplot. Okay, and that should run successfully if you're in Colab. If you run this and you're running this locally, you might have matplotlib, especially if you've installed Python through the Anaconda suite or installer package. You should have Seaborn if you've done it through Anaconda, but if you've like patched your environment through other things, then you might not have Seaborn. So go ahead and install Seaborn and then catch up with us in a bit. But luckily, these next handful of lines are pretty easy to understand. So remember, we're trying to recreate this bar plot here. So the first thing we'll do is we'll type in SNS, and then we're going to access this just like how we access pandas, SNS dot, and we'll type in the word, this is going to be crazy, bar plots. So now we're using the Seaborn library, and we're using the function bar plot. There are other ways to type in, like if you go to Seaborn bar plot, like it will show you in the documentation, like, oh, bar plot, like data, what the data is, X and Y and all these things. So I like typing data first. Sometimes people like putting X and Y first. I prefer putting data first because it makes sense to me. So we're going to say, we're going to declare a data set. Okay, I'm going to say data equals df3 because that's the data frame that has this, right? Or sorry, not df3. We're going to dfplt. Sorry, chat. Jesus. We're going to say sns.barplot, the function barplot. Now we're going to say data equals dfplt, which is the data frame we just made with hunter green only. And then looking at the data visualization we're trying to recreate, I know the X is the average, right, AVG, and the Y is the pitch name, right? So on our X-axis, so we'll do X-axis is average, that's AVG, right? AVG, that's our average. Now we'll do a Y-axis, pitch name, okay? And then if we want to render this, I tend, similar to being explicit with your join, saying what columns you want to join onto, I like being explicit about showing our plot. So I'm going to use the other library we brought in, PLT, and we're going to say plt.show. So this first line will make the graph, sns.barplot, this will make the graph, and then plt.show will be the line that actually prints it or plots it for us. Okay. So now we ran our package, we imported all of that, and then we did Seaborn or sns.barplot. We're using the barplot function. Data equals the data frame we made for hunter green, and we used our conditional filtering for that. Then we said the x-axis is our average, and the y-axis is our pitch name. And this is literally the same thing that we're doing here using our pivot table, right? plt.show also has some special characteristics. So I just tried to run this, right? Here's me running it a few more times, right? So when you show it, it also closes the temporary variable. That way you don't take up space in your environment, right? So whenever you print something visual, you're also taking up real estate in terms of space, right? So rather than holding like the data and all the artistic assets that develop this data frame, it just creates it as some sort of visualized figure and then tries to clear that data frame in the background from the temporary variable. At least that's what it says it does. But this is a boot camp about data science. If you want to know about back-end engineering and garbage collection, that's several boot camps from now. Now, what if we wanted to do multiple plots? I didn't just want hunter green. What if I also wanted Nickeladolo? I would have to go through the same process in the spreadsheet. So I would have to select my columns, insert, chart. There it is, but I want this as a bar chart. And then I'll use these as my labels, right? It doesn't seem like it takes long, but that's a long time. So if I wanted to do this for, say, all of the pictures, that'd be really difficult because I would have to be copying, selecting, and doing all these processes. So rather than doing this in a multitude of times, let's try to do this faster in Python. So we have a lot of the structure for reproducing, recreating our dfplt variable, right? So if we combine some of this stuff, like here's picture name, Hunter Green, dfplt, and if we take our bar plot info and we just put this all in one cell, right? So we have 4 lines, 1, 2, 3, 4, 4 lines here. And we ran this, we'd get Hunter Green. But say we wanted Nick Lodolo, just like how we did it here, or I think I'm like hiding Nick Lodolo's name here. He is. Nick Lodolo. Say we wanted to get Nick Lodolo instead, well, rather than doing all these button clicking methods, we could actually just change the name here, right? Rather than saying Hunter Green, we could type in Lodolo, comma, Nick, right? And that's the only thing we would have to change. And if we ran this, we would now have the average strikes in a bar plot for Nick Lodolo, right? Rather than doing it here in a spreadsheet, we now can do that here in Python, right? And we don't have to button click and waste seconds. We would waste less than a second if we just know the name off the top of our head, right? So we have Nick Lodolo, and then say we wanted to do both of them in the same cell, right? Green, comma, Hunter, Lodolo, comma, Nick. If we do it both in the same cell, we have that plt.show in there. Then here's our Hunter Green plot, and here is our Nick Lodolo plot. Let's say we want to do this with like a bunch of pictures. Say we wanted to do this with, you know, Graham Ashcraft. And then we wanted to do this with Alexis Diaz. Oh, crap. How does Alexis Diaz spell his name? Oh, there's a special character in it. Let's do Alex Young. Sorry, Diaz. Alex Young instead. Oh, wait, Alex Young didn't pitch. Oh, shit. All right, let's do Ian Jabot. Okay. So now we have like 4 of these, and this takes me less time other than like trying to figure out who pitched for us in 2022. This took me less time to do than if I was in the spreadsheet doing it, you know, copy for copy, right? So this seems like a lot of copying and pasting. So rather than doing this with a bunch of copying and pasting, chat, we're going to use some programming skills. We're going to do some computer programming 101 right now. So a for loop is something that you can loop over a set of code iteratively or multiple times, such that whatever you're looping over, whatever the set of information you're looping over, that's how many times you loop for, right? Rather than copying and pasting these 4 lines 4 times, we're going to first make a list, all right? We'll call this pictures equals, and remember a list is inside square brackets, right? And we're going to use these names. And since I know these work, I'm just going to copy and paste, right? All right, I'm just going to copy and paste. I'm copying over Nick Lodolo. Here's Graham Ashcraft. Here's Ian Jabot. Okay, so I've copied over our 4 pictures into a list called pictures. Okay, so if I run that and I take a look at what's in it. I have our 4 pitcher names, right? Hunter Green, Nick Lodolo, Graham Ashcraft, Ian Jabot. Okay, so I have this thing called pitchers. Okay. So now we're going to loop, all right? The first loop we're going to do is a really easy one. We're just going to print their names. And so for a loop, the syntax reads pretty easily. And so if this is the first time you're ever doing a for loop, just bear with me. It starts making sense once you start doing it a lot. Okay, so for the thing that the target, the first iteration or whatever the iteration is, we'll call this pitcher because we're looping over a list of pitcher. So for pitcher in the list that we want to loop over, pitchers, I'll type a colon. So this is the first part of your for loop. So this is saying for one thing in a list of a bunch of things, right? So you could rename this for one thing in your list, right? If this was your list, then this would be one thing in your list, okay? And in this case, for pitcher in a list of pitchers. So for one pitcher in a list of pitchers, we're just going to print the pitcher name, okay? So let's just start with a simple introduction to for loops, okay? For pitcher in pitchers, if we run this, you will print each of their names, okay? Another way to kind of check in your pitching list here, your pitchers, when you do this, pitcher is a variable still. Pitcher is actually still a variable that you can access. So sometimes I like seeing like, all right, so this just went from Hunter Green, Nick Lodolo, Graham Ashcraft, Ian Jabot. So pitcher looped through this list, calling each one out, and the last thing it did was it printed the name Ian Jabot. Okay? So, for funsies, sometimes I like just seeing what the last thing was. And so if I type in just the word pitcher, this actually says Ian Jabot. So this actually is a variable that says Ian Jabot as well. So for this thing in this list, it printed this variable. This is a variable as well. And you can access that variable even outside of the for loop. The reason I'm saying this is because you don't want to name this something that you care about elsewhere. Like if I name this for df3 in pitchers, this would be overwriting our df3 data frame, right? So this is a variable just like this is a variable. Just like dfplt is a variable, just like df3 is a variable. All of these things are variables, right? Okay, so if this is grabbing a variable and it's a name, then it's kind of like pitcher name here, right? So it would be like us doing this, except we want to replace pitcher name equals this name, and we just want to say pitcher name equals pitcher, the target pitcher in our loop, okay? So let's copy our code in here, just the 3 lines that plot, right? So you'll see that, you'll notice that there's indent here, right? So when I type in 4 pitchers in pitcher and I type enter, you'll see that there's a space here, there's indent, right? Whereas when I'm doing it on other lines, there is no indent in the beginning, right? So there is some indent here, and that's because we're inside of the loop. Okay, we're inside of the loop. So the loop, what it's gonna do is gonna take our list of pictures. It's gonna grab one of the names. It's gonna set that to the variable picture, and then it's gonna run this code. Now, we wanna copy this variable name, picture, and we're gonna conditionally filter df3.loc, df3 picture name is equal to the variable name picture, right? Just like here, where picture, the last thing that we ran when we did the print, we did Ian Jabot. Now we're going to loop over each one of these guys, right? Each one of these guys will be represented as a picture name and show it. For fun, just because we did it in the beginning, let's keep that print picture in there, right? We'll keep that in, that way we print the name of the picture at the top, and then we plot it. And then when it loops, it will change the variable to a new picture. It will print the new picture's name, and it'll print a new graph, right? So let's run this. Okay, so we just ran this, all right? We have a list of pictures, 4 pictures, and we said for picture, one item in our list. In pictures, this is a list of picture names. We printed the picture name, just like we did before. And then we ran our 3 lines of printing code, of data visualization code that we did before. And this code right here is essentially the same code as this, except rather than copy and pasting the chunks, these snippets of code, we are utilizing the repetition and putting that inside of a loop. And again, this is all coming from that data set, df3, df3, which is our picture name, pitch name, the average, their strikes, and the count, how often they threw the pitch. Okay, so if we have a column and we type unique, and we did this in day 1, so if we got unique values, right? We were doing this. We did this with, I forgot what we did this with. We did this with unique. You type .unique and it gives you this array of, and really this is a NumPy array, which is really a list. So we could see what a strike is. Yeah, exactly. That's what we did it with. So we did .unique, and then I took my code here, right? I don't need pictures. If I just take my unique, and rather than in pictures, I just did the unique straight up, and I ran through this, then it says I'm going to go through all of your picture names, all your unique picture names, and for each picture inside of your unique picture name, inside of your picture name column, and all of those things are unique. Let's print it, and then we'll set that to the new data frame, and then we'll plot that new data frame. Okay, guess what, chat? We're right on time. We caught up. We actually did all of day 2, and we caught up to day 3. So that's pretty amazing. Good job. Good job, campers. Good job, campers. I said that there was going to be a lot of homework. I wasn't lying, okay? Here's the easy homework. Here's question 1. Here's the question 1, all right? Remember, this is going to use stuff from day 2 and from today, because we didn't have homework on day 2. What is the average amount of strikes thrown in each attack zone? rename attack zone to attack zones. All right, question 2. For each Reds pitcher, the average number of strikes in each attack zone per pitcher or overall? Overall. This is overall, not specific for each pitcher. Question 2. For each Reds pitcher, how many times did they throw into each attack zone between release speed of 80 and 90? How many times they do it? Counting, right? That's a count. Each attack zone between the release speed of 80 and 90 miles an hour. Okay. What were the average strikes in each attack zone between 80 and 90 release speed? Merge the number of times thrown into each attack zone and the average strikes in each attack zone for each pitcher into one data frame. Attack zones. This is just from the original data frame, right? So if you're looking at DF, right, you'll have attack zone as a column name. So this should be kind of similar, right, to the merging average and count stuff, right? You know, but we're doing a little more with the conditional filtering like we did back in day 2. Okay, 3. For batters, we haven't done a lot with the batters yet, right, chat? We haven't done much for batting. What pitch types did they hit for home runs? For pitchers, what is their most frequently thrown pitch type? For each batter, what pitch types did they hit for home runs? For each pitcher, what is their most frequently thrown pitch type? Join batters and pitchers together. After joining, check to see if the batter and the pitcher ever matched up against each other in this data set. Make a new column. This isn't just for Reds batters and pitchers, no. It's for all the batters in the data set and all the pitchers in the data set. But the sort of cheat here is because it's always a Reds pitcher and always a Reds batter, you're gonna get some repeat matchups. So I know there's repeat matchups, but also this data set's small enough to where hopefully this join isn't gonna fuck your computer up. So make a new column that indicates if they did match up against each other or not. Okay, so that one should be pretty hard because that's doing filtering, that's gonna do some specific merging, you're going to also do some other filtering, and then you're gonna do a lot of joining, multiple joins, right? Because I'm looking at the answer right now, this one is gonna be, you should take some time to do this one. Okay, my answer is 12 lines. It's not the lines of code that matter. It's the fact that that's more than 2 lines. Okay. 4. Make a bar plot for 5 players and plot the amount of times they have thrown each pitch type. That should be pretty easy, right? 5. Use SNS.scatterplot, okay, a new function, a scatter plot, not a bar plot, and plot average as X and count as Y You can do this with the entire data set or use a subsample of data, i.e. if you wanted to only look at Hunter Green, that would be a subsample of the data frame, of the data, of the ag of df3. And here's some bonus questions. If it's too hard or takes a lot of time, do this some other time. What's each Reds pitcher's best and worst pitch type? Hint, more strikes are good for the pitcher. Here's number 2, and number 2 is more of like a project, but from the last 3 days, pick a pitcher and describe their ability to throw strikes. You can use any columns for your analysis. Some columns that could be helpful. Pitch name, of course. Attack zone, make a column for strikes. Make a column for balls. Make a column for different hit types in events. Home run or hit column. Make a column for your favorite team. Make a column for left-handed pitchers versus right-handed pitchers. Or left-handed batters or right-handed batters. Pick a few interesting columns and describe a pitcher's strike rate. Visualize it if possible. So create new columns, use some conditional filtering to make new columns, and then ultimately pick a pitcher and describe them through the new columns you've made. That's a lot to do before Tuesday. These 5 questions you should be able to do before Tuesday. It's a little more abstract, a little more creative freedom. And so if you present that in the Bootcamp channels, you can get people to review some of your code, the way you generate things, all of that, right? So definitely rely on the Bootcamp channels in Discord. If you're doing camp with some friends, or if you're making new friends in the Discord, that's all good too. Make sure you have people to bounce ideas off of. Let's summarize. We're gonna summarize day 3, but then I'm gonna do another summary about day 2 and day 3. So day 3, we brought, just like before, we created a data frame, and we also renamed that one of the columns from is strike to AVG or average, since we're taking the mean or the average. We're taking the mean or the average of the is strike column. And so we're renaming that to average. And we printed the head of it, and we could see pitch name, average. Then we did the same thing, except rather than doing average, we aggregated by count. So this is counting, not averaging, but counting the amount of times there was a variable or a value in each column row. And then we renamed this from isStrike to count. And then when we printed that out as df2.head, we see that we have count now. So the amount of times it happened, not the average. Okay, so we take those 2 data frames, we merge them on pitcher name and pitch name, pitcher name and pitch name. We merge that together and create a new variable, a new data frame called df3, and that has both average and count, and this is actually equivalent to our spreadsheet pivot table, which has pitcher name, pitch name, the average of is strike, and the amount of times a picture through it using a count, a type of count function. Okay. So we merge that all together, and then we conditionally filter for one picture, in this case hunter green. We save that as a variable called dfplt. dfplt, giggle Chad. How's the internship, dude? Then we have dfplt, and you can see there's 3 rows. We imported some plotting libraries, and then we made a plot using our new subset, smaller 3-row data frame for just hunter green. And we plotted the average strikes on X and the pitch name, or the type of pitch he threw, on Y. And then that was synonymous to the graph we made, also in Excel, right? Or not in Excel, Google Sheets. Excel too, you do this in Excel. So hunter green, we created this bar chart, and we're using this data right here. We did this again for Nick Lodolo, using these cells here to create this data visualization, this bar chart. And so for us in Python, we just took the code that we made for hunter green, and then we copied that, not just for Nick Lodolo, but we did it for Graham Ashcraft and Ian Jabot as well. So we copied the code, and then we just needed to change the picture name, and that allowed us to plot 4 different plots, one after another. Now, rather than copying and pasting all of this code one after another, we walked through for loop. So showed you how to create a list, and we selected a handful of names. And so we did for picture in pictures for an item inside of our list. Print the picture name, right? We print the picture name here. And then subset the data, and then plot the data that we just subsetted. And so we did that for 5 different pictures: Hunter Green, Nick Lodolo, Graham Ashcraft, Ian Jabot, and Derek Law. Okay, so introducing for loops. And that was it. And now you have a bunch of homework to do before Tuesday. True. Congrats on completing day 3, campers. True.